This is an open hardware project, and it's an open hardware project with no electronics to speak of. There are a few electronics. Let me get the electronics. So I want to point this out as the direction that open hardware is going. Just take one of those and pass them on. These are some lights. I don't think we need that light. It's probably okay without it.
Better for your video.
Better. All right. Okay. Cool. So. These things here are Hexayurts, and these ones are Burning Man, and you can see they're little houses, right? They're little sort of housing pod things, and they're incredibly easy to make. We'll just take a look at them. So I want to suggest that this is an example of open hardware taking a different direction, and this is the direction I think open hardware is going in. That it's becoming more and more like software where you just casually hack together physical artifacts. And my speciality happens to be housing and infrastructure and sustainable development, but you can do anything this way. So let's think about this if we take laziness and impatience and hubris, instead of being for software, as a way of thinking about hardware, right? What's the lazy, impatient, ambitious way of doing hardware systems, right? So these lights that I'm passing around have not been formally announced as open hardware yet, but they're $7, right? Look at that thing, $7. $7, right? Now the difference that makes as an open hardware project is you can sell these as open hardware incredibly cheaply in the developing world, right? And that's not the direction we typically think of as open hardware. Open hardware, typically it's microprocessors and all the rest of that stuff. No, there's a different direction here. So, laziness, hubris, and impatience, right? 150 square meters of buildings built by built by a team of 6 guys in 2 days. Right? Does that sound useful for CCC? Maybe? Possible?
How many?
Right. 7 buildings. Right, okay. 1, 2, yeah. 1, 2, 3, 4, 5, 6, 7 buildings. Right? Large, 150 square meters between them, 6 guys in 2 days, and it wasn't really very hard work. Right? This is a radical breakthrough building technology. This place, Maslowtopia. So you can see in the bottom corner we've got the Google Street View, the map. They do a high-res picture of Burning Man every year. So it's this huge camp of these units. I didn't even know these guys were building this thing. They just, after the event, I saw some pictures of it. They didn't ask me how to do anything.
Didn't ask your permission?
No, they didn't ask me how to do anything. They just downloaded the plans and built the damn things, right? So it's an open hardware project. It's in massive, full-scale replication because it's really, really simple. And the simplicity, right? Lazy, impatient, hubristic, right? The simplicity is what allows the idea to spread. So how do you make a Hexayurt, right? You need this very broad tape. You need to know how to make this thing called a tape anchor, which is like a knot where you've got a special way of using rope to make a fastener. So a tape anchor is a special way of using tape to make a fastener. And then you need this polyiso panel material that they sell at any Bauhaus. And that's all there is to it. It's a really, really simple system. And all of this stuff, you can look on the internet, you can find the references for how to do these things. Hexayurt in wood. So this really shows how the thing is put together. The wall is just a whole 1.2 by 2.4 panel, and this is the standard size for all industrial sheet materials, cardboard, plastic, wood, metal, sandwich panels. Can you think of anything else? I mean, it's just the standard industrial size for materials. The roof pieces are half of that size, so you take the piece, you cut in half, right? If you happen to be making it in plywood, you can take, you see these little wooden blocks, the little light colored sections? So that's just a piece of 2x4 that's been cut with a 30-degree angle on it, and you screw the building together with those. And you're done. Right? So, I mean, that's, thank you very much, that's the talk. Right. So, okay, there is a little more to it, right? But, I want to make the point that actually, that picture is pretty much all there is to know about the basic Hexayurt. It's that simple. If you happen to be making it using this kind of material, you need to get the tape and you need to know how to make a tape anchor. If you're making it out of this kind of material, you need to know how to make these little wooden blocks and you need to know how to cut that much plywood and screw it. But really, this is all there is, right? And then there's all the stuff that we've learned on top of that. But the basics are so incredibly simple that right now, in 5 minutes, you've all acquired the basic knowledge of how to make hexayurts. And if you had to figure out the actual details to make them out of any given material, you're smart people, it's not going to take you very long. It's an idea that spreads incredibly quickly. So this is the first hexayurt that was ever built. You can see there's a little solar panel that drives a cooling system called a swamp cooler. It's 1.2 meters squares that it's made out of. Burning Man 2003. God, that was a great party. So this is the configuration space of hexayurts, right? You've seen the very basic ones in 2 materials. Geometry, the material choice, and the construction technology are the 3 big variables. So this is the different kinds of hexayurts that exist. That's called 6-foot hexayurt, stretch hexayurt, pentayurt, which is a nice steep angle on the side for dealing with snow, standard hexayurt, stretch hexayurt, double stretch, double height, double stretch, right? And that's your configuration space. And obviously you could connect the damn things together any way you like, right? Big hive, warren type things, pretty easy to do.
We can make a giant sea out of that.
You could make a giant sea out of that pretty easy, right? Or you could make a bunch of small seas, or I mean, it's.
Everybody see where this is going.
If you had enough hexayurts, you could make a big sea in any font you liked.
How much do we need to represent this palm that you see at the window behind you?
One of those. Well, if you've got 4,000 people coming, right? 4,000 people at 5 people per hexayurt gives you enough hexayurts to do quite a high-res version.
You do know that the original space station has a diameter of a mile?
Yes.
Okay.
It's about the size of Burning Man.
I think it's about
It's entirely reasonable.
2,342 people.
Maybe.
That's fine. Right? It's you wind up with 400 hexayurts. So it's a 20 by 20 pixel array. You'll be fine. So other ways of constructing these things, right? This is the kind that you make instead of with panels with cubes. So you have a frame like this. The advantage this has over a standard geodesic dome is there are only 2 connectors, right? There are only 2 section pieces. So the triangles are full length, and the hexagon around the top are missing a few inches per piece, a few centimeters per piece. So it's only 2 components. And the walls are vertical. So you could take 2 of these units and connect them directly together with no connection problem. So you can actually have very modular pieces. And the materials are sized in such a way that you can make a fabric cover really easily. This is the fabric covering instructions, but you can make a zero-waste fabric cover if you want to go down the route of having framed. We're also at the point, because the project started, right, 2003. By 2011, we've also got new designs that came from other people. So this is a thing called an H13, and you can see it's still using whole sheets and half sheets. And there's this clever thing they do at the front that gives you a full 2.4 meter entryway. Because the conventional hexayurt has a low entryway, which is a pain in the ass. This one has a high entryway, so it's easy to walk in and out of, and it's only 1 more panel. This is one they made for a party in Canada in the middle of winter. And this is actually quite a clever piece of engineering. So it's 2 sheets of thin plywood sandwiching around insulation foam, and you see these yellow bands around the side? It's the webbing strap that you use on a truck to hold the load on it that's being used as a tension ring to stop the building falling to pieces. So probably you just open that strap and you take the building down again. Right? But that stuff is like $20 a strap and has a breaking strain of 8 tons. So why not use it for construction, right? Laziness, hubris, and impatience. Right? Can you imagine a lazier building for the middle of Canada, right? Could it possibly have more impatience? We can't even be arsed to use building materials. We're going to use a strap off a truck, dude. Then take a look at these things, right? This is a little longer on the hubris side. So there's your standard hexayurt in the middle, and then there are these 2 dirty, great big domes. Right? Look at the size of this thing. 45 square meters for 30 sheets worth of material. Right? So the ratio of material to surface area, right? Each board is 3 meters. It needs 30 boards. So you get 90 boards worth of materials for 45 square meters of space. The thing is basically a perfect hemisphere. And it only uses whole boards and half boards. So all of those shapes are 1.2 by 2.4 meter boards, either cut in half or used whole. Right? Whoa. Right. So suddenly we were beginning to talk about really big construction with zero waste and no screwing around. And because all of these Hexayurts are using the same components, imagine you've got a standard kit of parts and you rearrange the buildings that you need for a given event. Now we need lots of small ones, now we need some big domes, so it's all the same connectors, it's all the same panel sizes, it's a flexible architecture. Interesting things happen. And I want to make the point, the reason that Buckminster Fuller didn't get to this stuff is because Buckminster Fuller was optimizing for the wrong thing. He was optimizing for minimum mass, which is of course what you want in a space station. If you've got if you've got a mass-dependent drive technology in 0G, mass is your critical factor. But if you're operating on the ground, with in the gravity well, with standard materials from an industrial supply chain, you're looking for a different optimization. You don't want minimum mass, you want minimum waste. And that means using a different branch of math, in this case concave tiling. So it's the same mathematics as for things like Penrose tiles to figure out whether you can get it to tile. And we get back to the hubris part. I think if they'd had this technology in the 1960s, the hippies would have won. Because all of those, right? Because the problem with geodesic domes was that the damn things were really hard to build and they always leaked. So all of the communes failed because they couldn't afford to build houses. Right?
Interesting theory.
Places like Drop City, all of the houses leaked. Everybody was unhappy. People just decided to go back to the suburbs because they wanted a house that didn't leak. I'm telling you, this is the technology of victory. This is how the freaks take over the earth. Look at the size of that dome, right? There are plans on Thingiverse to download the laser cut plans to make these domes. If you just look for Neurodiesic or Hexayurt, right? But look at how big that is to a standard Hexayurt. It's huge. You should build 4 of them. And this notion of having a single panel repository where you can reconfigure the buildings that you want using the same basic components, I think that is the way that this stuff is going to go. I don't know how to make the panel connectors yet to make it possible, but when we figure out how to do that, then imagine just being able to rent from some central service 27 panels for 4 domes you're going to use for a weekend and then give them back on Monday morning. Configurable building. So we covered the geometry. Everybody agree we've got a pretty large configuration space on geometry? Wait till you get to materials, right? These are the ones...
Up the microphone a little bit.
Okay.
Thank you.
So these are the materials we've done already, right? And it's basically anything we could get our hands on. You take a look at it. Yeah, I could make a Hexayurt out of that. Right? The connection technology changes a little depending on your material. Okay, this one is heavy, we're going to use bolts. This one is light, we're going to use tape. Maybe we can make some little metal connectors. You just sort of look at your material, you figure out your connector, you apply the connector to the material, there's your Hexayurt. We haven't done very much with metal because it's expensive and it's a pain in the ass. We haven't done very much with structural insulated panels because they're expensive and they're a pain in the ass. The really hot thing that we haven't done yet that I'm really eager to do is ferrous cement or spray concrete. Do you know concrete sprays?
Yep.
Okay, so imagine you build
I do, the rest of them probably does.
Alright, so you put concrete, you put it in a big spray and you spray it. It turns out to be a little harder than that in practice, so there are companies where they come and they spray your thing with concrete for you, right? Your neighbour has a car that's really annoying you, you come, you tell them it's your car, they spray it with concrete. So you build one of these Hexayurts out of this lightweight foam material, you spray it with concrete on the outside, you spray it with concrete on the inside, now you have a highly insulated concrete permanent building. And it's only 1 centimetre of concrete inside and out, so the building is still relatively light. So you can do things like build them on top of the roofs of other buildings. Right? Now, this has potential, nobody's done it yet. So this other thing about printing designs in corrugated plastic, highly printable materials like corrugated plastic, you print anything you want on the outside of a Hexayurt. So imagine taking a picture of a place, doing the 3D projection to know exactly what you've got to put on each side of the Hexayurt, and then printing a camouflaged Hexayurt that's completely invisible because it looks like you're looking straight through it. All of this is possible. Okay, construction techniques.
That only works from a single point of view.
Well, maybe, but the eye is very lazy, so it's possible that you could get something that worked from multiple points of view, and it looked a little bit wrong as you walked around one side, but you really wouldn't notice. But I don't know, nobody's tried it, so we've got to do some experiments, right? So there are lots of different ways of doing this stuff, depending on whether you want it to be just a one-off unit, whether you want it to be folding, whether you want it to be folding as a single component. Again, it's a big configuration space. This is a completely folding Hexayurt unit that was built by some German army dudes in Stuttgart for an exercise. Oh yeah, the military loves Hexayurts, they're super into them. Which is a long story. So, that building fits as a single module. And I've got some video in here, I can show you the video in a second. Or if you just go to hexayurt.com/fold, there's all the folding Hexayurt videos. This is a different kind of folding Hexayurt, so this one is much bigger, and it's two components. The triangles are the roof and the walls are the walls. The rectangles are the walls. So the whole roof fits out as this single kind of star thing, and then you pull the star thing open, and there's your roof. And this happens to be built inside of a gigantic geodesic dome in Eindhoven, which was built there by nobody really remembers who the Red Cross use it. So this is kind of where I see the future of this whole project, right? Because it's open hardware, it's beginning to become commercialized. There's a resale market in America for Hexayurts. So people build them from Burning Man and sell them afterwards, and the market value seems to be about $500 a unit. Getting to this point where you can spray the damn things and make them permanent it's got to be the way to do this, right? That opens up a whole new set of terrain. Also rural squatting, so you take a van, you put 12 Hexayurts in the back that fold up, you drive out to an abandoned farm, you live in them for 3 months, somebody comes and serves you the court order and says you must leave, you put them back in the van and you drive 20 miles down the road. It's all horizon. This is also a really important little detail. Ultraviolet light eats everything. So the big advantage of the Hexayurt is that you can use a foiled surface, right? These foiled surface panels. That stuff will last a really long time in the outdoors. So the ability to have rigid buildings which last a long time because they've got an appropriate UV protective surface is really key to getting this stuff to work if you want multi-year buildings, because UV will eat any kind of plastic eventually. And this thin shell concrete thing, that's going to come. So that's the Hexayurt part. Let me throw you two other cool things. Cheap ID is a barcode and crypto-based solution for managing digital identities. So you take a passport, you generate some digital signatures that you've seen the passport, you put the digital signatures on a piece of paper together with a JPEG of somebody's face, and now you have an anonymous digital identity that's still backed by nation-state credentials. What you would do with that, I don't know, but you're smart people, you'll find a use. Right. There's got to be some use for it, right? Like ID cards for things where you want people to get in, but you don't necessarily want to reveal anything other than the fact that somebody's allowed there, maybe. And then there's this thing, which is the dartboard of death. Of death.
Yeah, I perfectly understood that part.
Okay, all right.
Maybe you go a bit slower at that point.
The dartboard of death? No, it's very obvious, right?
You could
So,
probably call it the dartboard of doom.
dartboard of doom.
Exactly. Well, look.
So let me explain this before we get silly. Right. So there are only really 6 ways that people die, right? Too hot, too cold, hunger, thirst, illness, injury. And the services that protect you from dying of these things are split through different levels of society. Individual person, household, village, community or city, region, country, and world, right? So you have this notion of a stack of interlocking services that provides essential services. This is a design tool that I used when I was thinking about doing things like large refugee camps. So it's a way of figuring out that we'd actually covered all of the essential needs with an interlocking set of core technologies. So this is sitting out there, again, it's under Creative Commons license. It models everything up to including state failures. There's no software support for it yet, so we're doing it all with spreadsheets. Spreadsheets suck. So this is a really useful analysis tool, and it's the kind of thing that I'm trying to begin to think about developing some software to support. And if anybody's really interested in this stuff, give me a shout. So that was it. I'll turn off recorders and then take questions.
Yeah, show us the video of the army.
Oh, you want to see the folding videos? Okay, hang on a second. I don't think I've put this machine on the network. Right? Is that the right network?
No, you want to run C-Base 1. Yeah.
Sorry, so there's the crap animated GIF. Have you guys seen these, by the way?
What?
It's a €15 USB chargeable, awful, horrible quality loudspeaker, but they're incredibly loud and dirt cheap. So now I can show you. Let's see. So this is the German Army dude video. Wait, what? No, go away.
Shall we try it again? Well, you know, I mean, one of these days we'll get just the right angle and we'll understand how to make it work. And once we understand why, then it'll be easy. Yeah, once understanding comes. Understanding comes. So let's just pop it closed again. Yep. Very close. 1, 2, 3. 1, 2, 3. Close.
Oh, it's called
Why does it
polyiso.
open that easily?
Polyiso.
It's so hot, makes it so hard.
It's a cheap insulation
Yeah, I
board.
don't know either. That's why I'm asking you. Okay. So let's give that a try. Yes. Woo! Okay, you got it. Now, what did we do that made it easy that time? Pulled on the two opposite ends.
So there's that. This is the Red Cross one, the red prototype I did for the Red Cross. Sorry, it's an animated GIF. There is video, but it's really slow. Let's see. This is a smaller size that somebody did at Burning Man. And then, let's see. The Swedish one.
Put out the wall. Okay.
Roof herd, retreat! Not through the funnel. Oh, your feet are gonna get wet. Go round, go round. Oh, what are we gonna do? Okay.
So this one, they had material that was 3 meters by 1.8 meters. So we modified the design slightly and wound up with this huge structure. It's like 24 or 30 square meters in size. Just
Keep
enormous.
opening out the wall. 1, 2, 3, 4, 5. That would be the problem. Okay,
There's
what's
the
wrong with the
6th
wall?
side.
Okay. Okay, so roof folks. Now here we're going to have a bit of a problem because we don't want the bottom of the roof to get wet, do we? So we're going to get everybody and we're going to open the roof in midair. Okay, does that sound remotely possible?
So this is another little clever thing that we've learned, which is what I call gang carry. So if everybody involved in a lift is carrying less than about 10 kilos, maybe 15, you get very, very fine motor control of the lift, regardless of how heavy the object is. So you can actually take a Hexayurt that's made of plywood, right? So it's 12 sheets of plywood, 3/4 of an inch thick, and you can lift it with 4 people or 3 people on each side. So you've got a gang of 18 or 25 people doing the lift, and you can just pick them up and walk with them because it's got so many people lifting it that each individual person is only taking a little weight. And that turns out to be a really important technique for doing this kind of sort of lightweight construction. And it's very hard to get people to do because everybody expects lifting a heavy object to be hard work. And the idea of using so many people that lifting the heavy object becomes easy, people just can't get their head around it until they've done it. So everybody's looking confused, like, shouldn't this be heavier? What are we supposed to be doing here? And then you start moving, and instinctively everybody kind of coordinates, and it just sort of works. Everybody gradually does the little thing. You can see we're on ice here. It was quite sketchy. There we go. Right. So people have to peel off the front, run around, go inside, and then take their edge back again. So it's this very slow, very careful movement, but you could do it even in plywood. Even if the materials are really heavy, it still works. No, you don't put doors and windows in Hexayurt, so we silly. So it's kind of a ritual of putting the roof on, taping the roof in place, and then cutting the door. We kind of do it for fun, but it's also a really nice moment.
Or beam inside.
Yes, yeah. Well, I mean, if you've got a space station and you can use the transporters, right, you're fine. Let's see. We've seen all these.
I have one question for the geodesic stuff.
Yeah.
Which material you would say?
Well, I'll tell you what.
For the geodesic questions?
When I turn off the cameras and record her, so you guys feel comfortable asking questions, and then we'll take questions. All right. So, thank you.